So today we are going to discuss an interesting problem on graphs, capture regions on board. Problem statement is given a 2D matrix A of size n cross m containing x and O's, capture all the regions surrounded by x. A region is captured by flipping all O's into x in that surrounded region. Let's take an example. If uh, just a second. If we have a 2D matrix like this, then we'll convert all the O's surrounded by x into x. Like we'll convert these O's into x. And we will not touch these O's, as they are not surrounded by, this one is not surrounded by x from left, this one is not surrounded by x from below, this one is not surrounded by x from below and from right, this one is not surrounded by x from top and from right. So we'll leave all such O's and its connected components, and we'll leave it untouched. So basically, we will leave all the O's which are either on first row, on last row, first column, or last column, and all its connected components also. Let me take another example. For example, we have another 2D matrix like this. We will leave these zeros untouched. This one, and this one. We'll leave all these zeros untouched and we'll convert the remaining zeros into x. We'll convert this into x. We'll convert this into x. We'll convert this into x. So the approach we are going to follow is that we'll do a Bss traversal on first row, on first column, on last row, and last column. And if we encounter any zero, we'll look to its left, we look to its right. We basically do a Bss traversal for that element. We look to its left, we look to its right, we look to top of it, we look to bottom of it, and if we encounter any zero, we push that into Q and mark that element as some other letter. Let's say we mark it as A. We'll mark it as A and continue. Similarly, we'll look to its left, we'll look to its top, we'll look to its bottom, we'll look to its right. When we come to its right, we encounter another O. So we'll mark this as A and push its neighbor into the queue. So now coming to this one, we'll mark this as A, we'll look to its left, we'll look to its right, we'll look to its top, we'll look to its bottom. We basically basically see all the four directions, and if we encounter any zero, we just push it into the queue and mark it as A. So our 2D matrix looks like this when we mark all the unwanted O's as A's. Now just see this matrix. We have replaced all the unwanted O's by A's. So now what we will do in the final step is that we will traverse this 2D matrix, and whenever we encounter a O, it simply means that we have to convert that O into X. So we'll convert it into X if we encounter an O. And if we encounter a, it simply means that we do not wish to change that into X in the first place. So we'll undo the step that we have done previously and we'll mark it as O back. We'll mark all the A's as O's. So finally we'll end up having a 2D matrix as we'll end up having a favorable answer. So let me summarize what we have done so far. We'll first traverse first row, first column, last row and last column, and if we encounter any O here, we'll change it to A, implying that this O is simply unwanted. And we achieve this by doing a Bss traversal of first row, first column, last row, and last column. And in the last and the final step, what we will do is we'll simply traverse the entire 2D matrix, and if we encounter any O, we change it back. If we encounter any A, we change it back to O, and if we encounter any O, this simply means that we intend to change that O to X, and we'll change it to X right away. So now let's come to the actual implementation or coding part of the problem. Uh, so basically, we'll maintain a queue for multi-level Bss traversal, and it will store X and Y indices of each element. We'll first traverse the first row, first column, last row, and last column. And if we encounter any O on first row, first column, last row, or last column, we'll simply mark it as A and push it into the queue. Let me explain what does it mean. Like if we have a 2D matrix like this, we'll basically go to the first row, and if we encounter any, let's say, if we encounter any O, we'll mark it as A and push its X and Y coordinate into the queue, and continue. And when we come to the first column, we come to know that this is a 0. We'll again push it into the queue, its X and Y coordinate into the queue. And if uh, while traversing the last row, we again encounter a 0, we push its X and Y coordinate into the queue. So our queue has now X coordinate of X and Y coordinate of this, X and Y coordinate of this, X and Y coordinate of this. So now we'll basically do a Bss traversal of these elements that we are pushed into the queue. So now basically what we will do with this, what we'll do is that when we come to this element, we'll look to its left, we'll look to its right, we'll look to its bottom, we'll look to its top. We'll look in all the 4 directions, and if we encounter any 0, we'll push that into queue and continue the process while queue is empty. That's the standard Bss traversal procedure. So we do not encounter any 0 here, so we continue. And coming to this 0, we look in all 4 directions, and we encounter a 0 on its right. Yeah, we mark this as A, push this into the queue, and mark this as A. Now we'll again look in all the 4 directions, and we encounter a 0 at its top. Now again we mark this as A and look in all the 4 directions. We encounter no 0, so basically we have completely traversed the whole component. Now we'll come to this last 0. We'll convert this to A, and we'll look in all the 4 directions. We do not encounter any 0, so we basically we continue. So we have successfully traversed all the X zeros which lie, all the zeros and all its connected components which lie on first row, first column, last row, last column. So basically we are doing this here. We'll traversing all the 4 directions using these arrays. We'll traversing top, bottom, left, and right. And if we found any element as 0, we'll mark that as A and push that into the queue. Now finally, in the last step, what we will do is we'll traverse the entire 2D matrix, and if we encounter any A, then we'll simply convert it back to O, as we didn't wish to change that in the first place. And if we encounter any O, we'll convert that into X, and finally we'll achieve our intended answer.